pals, Mr. B here, bringing another sweet, wicked, awesome math video. This one on one of my favorite topics, limits at infinity. So we've already done a bunch of different finite limits, factoring, conjugate, common denominator, absolute value. Now we get into infinite limits. So a limit to a finite number like 0, 1, 2, 3 is often concerned about, what's happening at a specific point. Limits at infinity are concerned about very big values of x. So what happens as x gets very, very big or very, very small? So I'm pointing on the number line if you can't tell. So in terms of graphically what this means, they're actually called horizontal asymptotes. So what does the value of the graph tend to? Does it tend to a number? Does it tend to infinity? Things like that. So we have a very specific method for doing it, and let's dive right in. But first, if you like this video in any way, please give me a like, share, comment, or subscribe. I would love you to do that. All right, bam, into the screen. All right, so limits at infinity. So these are different than finite limits that I said. And like that, there is a different way to do them. So first of all, you look at this, and a lot of my students fall into this trap. Square root, conjugate every time, right? So no. The first thing you need to look at is, oh my God, look at this thing. This thing right here. What am I going to do? There is a negative infinity sign. So what that means is we have a different technique to do it. And that technique is dividing. Well, my technique is dividing, and it's not mine, but that's the one I use. Dividing by the suspense is killing me. Highest power in the denominator. All right, so the highest power in the denominator. So we don't want to get fooled either. Though we got to be really careful, use our brains when we're doing this. So notice this big old fat root here. So there's an x squared in it, and you might be jumping, x squared, highest power. Well, we got to apply any operation that might be around it. So in our case, the square root of x squared is just x. The same thing would apply if it was like a 2. So if it was like, an x inside and there was a bracket on the outside with a squared on it, then our highest power will be x squared. So in our case, though, the highest power in the denominator is actually x. So what we do is we divide every single term by x. A little bit annoying, but that's the way she goes. And of course, it's to negative infinity. That's significant as well. So we'll divide everything by x. So we go 2x divided by x, and then plus 1 divided by x, all over 5x divided by x. Now this cheeky root here, we got to be careful, because inside a root, x, in order to be just x or divide by the power of x, we actually have the squared, because the square root of x squared is x. So these get divided by x squared. So just keep that in mind when you have a square root. And that's the most common scenario, is you have a root as opposed to like a bracket with a squared on it. So just keep that in mind. So now what we do is we simplify where we can. So I'm going to take out my red pen, and I'll cancel these x's just like that, and I'll cancel these x's. These go away, and that's all that really cancels. I'll go back to the old trusty black pen. So we end up with the limit as x goes to negative infinity, and I'm going to rewrite 2 plus 1 over x, all divided by 5 minus square root 9 minus 4 over x squared. So this limit obviously takes a little bit of a sort of a different flavor than the other limits. I would consider these to be a little bit easier than conjugates, common denominator, but there are a couple little tricky things that we got to keep in mind. So when we have an x on the bottom like this, and normally what we would do once we sort of simplify a little bit, we would think about subbing that infinity into here. So what would a number be like 1 divided by infinity? What would it actually give us? Think about 1, and infinity is like the concept that's just like a ginormous number. So if we think about 1 being divided by something completely huge, like a cajillion billion or something like, something like that. So what we would end up with, 1 divided by an extremely large number, would pretty much be 0. So whenever we get a variable left on the bottom, those are places where you're going to end up with 0. So when I go to rewrite this, I drop my limit, and wherever I have an x left on the bottom, that turns into a 0. So I get left with this situation. Now, while I'm here, I should also mention this, because when I'm going to rewrite this, I'm going to leave this stuff for a second, is that the negative infinity is significant. So we have negative infinity. What that means is our square root is going to actually be negative. And positive infinity means our square root is going to be positive. So the trick that these little cheeky math question inventors tried to, and that probably was me, try to trick us by putting this minus in front of this guy right here. So that minus, we don't even think about it. Like, we make the decision on whether it's plus or minus root based on the infinity sign. So I'm going to put that negative in there right now. So the reason why they put that there is they're going to try to figure out who actually knows what's happening with these signs. So that minus does not contribute to whether the root is minus or plus. So if I have a negative infinity, I need to have a negative root. So that just means that in this case, I'll have 2 minuses, it turns into a plus. So it becomes, what's happening here? Try again. Technical difficulties. Here we go. So we got 2 on the top. And on the bottom, I end up with 5, and then the negative, or the subtract and the negative becomes plus, and then the square root of 9 is 3, and then becomes 2 over 8, which is indeed 1 over 4. So again, a really different technique than finite limits. Let's try question number 2. So again, if I'm going too fast, that's the beauty of YouTube. Pause, pause, pause. So, I don't know why that's highlight like that. There we go. So again, we look at this thing, we look for the highest power, and we're not fooled this time at all. So we got a squared, x squared underneath the square root, but that's not the highest power because the square root of x squared is just x. So technically the highest power is indeed x. So we go to limit as x goes to infinity, and that infinity is plus infinity, which means we got a plus root. All right, that's one of the first things I would usually do, but I didn't in the last one because I wanted to keep you in suspense. So then we're going to divide everything. I don't know how many times I can say everything. Every single thing by that highest power of x. And then underneath the root, of course, x is not x. It's x squared. So 16x squared divided by x squared minus x divided by x minus 5 divided by x. So we got to be, or not x squared. I just told myself and then I forgot. All right, so let's go ahead now and see what we can cancel. And I don't know why I divided that one by 4. And you're probably like, what an idiot. Delete your YouTube channel. Quit teaching. Someday. All right. Nah, I'm kidding. I love it too much. I would never quit. You can't get rid of me. All right, so x cancel. These x's cancel. My x squareds cancel. And then I'm going to get one of these x's is going to go. And then don't forget, I'm left with a 1 on the top. So if I cancel everything on the top, there's a 1 there. And then nothing cancels with that guy. So that can be easy to mess up, but hopefully you don't, because I just told you about it and you'll remember everything I say. All right, so then we got limit as x goes to infinity. So I got 3 over x minus 4. All divided by 2 plus square root 16 minus 1 over x minus 5 over x squared. So remember, my little trick is that wherever there's an x left in the denominator, slap a 0. Everywhere else, get us a number. And you might be asking, what happens if an x is in the numerator? Don't ask me those questions. That's crazy talk. No. So basically, it's you end up with an infinity sign there, which means the limit isn't. It's not going to tend to anything. It's going to tend to infinity. So those are boring. You're never going to see those. Well, not very often anyway. Now that I say that, you're definitely going to get one, right? And you'll be like, oh, sir said I never got one. So they happen, but rarely do they happen. And when they do happen, they're obvious. Okay. So then 2 plus, and on the bottom here, I got 16 minus 0 minus 0. My students always get upset when I do that, but I like to just emphasize that I know what I'm doing. So then I'll tighten this up a little bit. So I got negative 4, and then it's 2. So the root itself, plus infinity plus root, so that's not going to cause us any problem. So square root of 16 is 4. So I got negative 4 over 6, which is negative 2 over 3. And there's another lovely math video completed, guys. So if this helped you even in the tiniest little bit, I'd really appreciate you dropping a comment, giving me a like, share, all that stuff. I know people on YouTube are bagging you all the time, but come on, look at me. I'm just a normal person. I'm not like some big fancy YouTube star. I'm just trying to help out my students while being slightly. I want to just have a humble brag over all my fellow teachers that I am the biggest YouTube star at my school. All right, so thanks for watching, and as always, I will see you guys in class.
A lot of boring math later.